if you are scheduled to take the final exam, I need your study guide by the end of class on Wednesday. Seniors that are scheduled to take the final exam, I need your study guide by the end of class on Wednesday. If you want to turn it in early, I'm always happy to take it early. If you're not sure if you'll be here or whatever, feel free to give it to me early is fine. But I need it by the end of class on Wednesday. Huh? I gave it to you like 2 weeks ago. Yeah, it's long. Because we've done it's cumulative, so it's like the whole semester. Yeah. But it'll help for the final a lot. So try to do it, Plus you get the extra credit for it.
How much extra credit?
5 points. Yeah. Well, there's less than 100 points on the final. I don't know, like 80 or something. So it's like 7% for the study guide, which is pretty doggone good deal. All right. Juniors, we're going to continue on in chapter 15. We have one more section to do. That's section 15.5. This will be at least a 2-day lesson. We'll see. But that's our plan for today. Juniors, seniors that are scheduled to take the exam, get crack-a-lacking on your study guide. Let's be non-disruptive, so keep your conversation to a minimum while everybody else is still doing about 20 minutes worth of stuff. Ooh, you're the first one, Ethan. Last one to class, first one to turn in.
Extra credit, right?
It is.
I actually get extra.
Extra. Read all about it. Yes. That's fine.
Thank you.
All right. Today we're going to talk about the mathematics of finance. So this is an application of exponential functions that should be quite important. So the first thing we're going to talk about is simple interest. So to calculate simple interest, we're going to use this formula. FV is equal to PV times the quantity 1 plus Rn over 100. So the FV is our future value. That's the value of that account or that money at some future time. PV is our present value. That's how much you're initially investing. R is the interest rate as a percentage. If you want to convert the interest rate to a decimal, then you drop the over 100 piece. That's what the 100 there is doing, though, is just converting that percentage into a decimal. And then N is the number of years. So if we are going to do an example, says if you invest $2,000 at a 6% interest rate, how much total money do you have in the account after 3 years? So because you don't see the word compound, that's telling us this is simple interest. So the 2,000, that's our present value. The 6%, that's our R. How much total money, that's our future value. And the 3 years is our N. So if we fill in, that's what we're doing. So at this point, it's calculator time. I get $2,360. Now, what this simple interest is doing is you're earning that interest on only your initial investment. So the interest you're earning is the same every single year because all you're earning interest on is that initial $2,000. Another way we might calculate interest is doing compound interest. So you'll notice this formula, FV is equal to PV times the quantity 1 plus R over 100K to the NK, is the letters inside of this, or the variables, are almost the same as the simple interest formula. There's just one new guy. Which is the K. The K is just going to represent the number of compounds per year. So typically in these story problems, that value for K is going to be hidden inside of a word. Like it might say compounded monthly. So how many months are in a year? 12. That would mean K is 12. If we'd said compounded weekly, what would K be?
4.
Nope. Weekly. 52 weeks in a year. What if it's compounded daily? 365. If it's compounded quarterly, K would be 4. Semi-annually, 2. Those are kind of the common intervals. So again, like K will not be spelled out with a number. It'll be hidden inside of a word, but it's not hard. It's just like how many of these happen in a year? You know, like stuff that we learned in grade school. So let's look at almost the exact same problem here as an example. If you invest $2,000, 6% interest rate, compounded annually. So when I hear that word compound, that tells me I'm doing compound interest. So I need to make sure I'm using the compound interest formula. Everybody's okay there? All right, so to fill this in, $2,000 initially, that's my present value. 6%, that's my R. Annually, that's my K. We're looking for total money. That's my future value that we're looking for. And then 3 years is our N. So if we fill this in, oops, I guess I should probably write it this way. Everybody cool with how I figured out what goes where and how to fill in? Pretty easy. I'll plug this now into my calculator. Notice I'm not going to bother to type in the times ones. And here, notice we earned a little bit more money in this situation, right? About 22 bucks. So notice, the amount of money earned, the future value is different. So how is compound interest differ from simple interest? In simple interest, the amount of interest earned is calculated only based on the initial investment. Compound interest, the interest earned is based on the value of the account. So essentially, you're going to be earning interest on top of your interest, right? That's the compound nature. Now, over the short term, Mr. Kulik, that's not a big deal. 22 bucks over 3 years, big whoop. What if we did this now for 50 years? So if I did simple interest for 50 years, that's $8,000. If I did compound interest, that's almost $37,000. Holy smokes, that makes a huge difference. That's the idea here. So, over the short term, simple interest, compound interest, not that big a difference. Compound interest always will be better. Shh. But over the long term, like 50 years, look at the difference. Right? It's like almost 5 times more with the compound interest than the simple, right? That's huge. All right. There was another part to this question. Said, how much money did you gain in interest? So in general, the amount of interest earned is going to be the future value minus the initial investment. That'll tell us how much money we've made in interest. So in this case, I would have earned $382.03 in interest. So if you're ever asked how much interest is earned, it's just future value minus present value. Doesn't matter the type of interest you're calculating. That's always going to be like, how much money did we just make doing this investment? Well, it's whatever we end with minus what we started with. That's how much we made from the investment. Oh, yeah. Now, we talked about this a moment ago, but I'm going to drop this into the notes also. So remember, we had the K was always going to be hidden inside of words. Again, these are the common words that we're using and the corresponding value of K. So again, probably stuff we already are good with because it's just like how many of this time interval is in a year. Hopefully nobody asks you for seconds, unless you're a big musical theater fan. Anybody? No? No fan? There's a musical called Rent, where one of the songs is about how many seconds there are in a year. You remember? Yeah, you're singing. You had the tune right. I don't remember the number anymore. I've seen it. Yeah. All right. Another example. In this case, the point of this example is to look at how big of a deal the number of compounds per year makes, right? So the number of compounds per year, more is going to be better, right? That should be pretty clear. If we do more compounds in a year, that's going to be more interest earned. You're going to end up making more money. The question we want to look at is how big of a difference does it make? So if I keep everything the same and just change the number of compounds, does it make a big difference, a little difference? So that's what we're going to check. So we have $800 investment. That's our present value. 7% interest. That's my R. 5 years. That's my N. How much money will we have in the future? That's a future value. And then we're going to look at all these different values for K. So again, annually K is 2, semi-annually K is 4, etc., etc. So I'm just going to set it up kind of like this, and then we'll go into our calculator and just do the, just change things one at a time here. So compounding annually, we end up with $1,122.04. So if I do that semi-annually, how much difference do you think that's going to make? Big difference, little difference, no difference? Let's check. $6.50-ish, $6.50. Not a big deal, but it's not nothing. So that was like $6.50 going from 2 to 4, or from 1 to 2. If I go 2 to 4, I'd expect what, like another $6 difference? No, not even. Like a little bit more than $3. Huh. Kind of surprised, right? Okay, well, we're going from 4 to 12. That's 8 more compounds per year. That should make a big difference, right? Maybe I'll see a big jump. Over here, we just had 2 changing 2 compounds. Here we're changing 8 compounds. Oh no. It's like $3. Not even. Less than $3. Barely, a little more than $2 actually. Oh. I'm starting to get a bad feeling about this. Like this doesn't make much difference here. I mean, it still helps, right? It's like something. If I go 12 to 52, that's 40 more compounds. And what I pick up? Less than $1. All right, let's go all the way to 365. That's over 300 additional compounds. What do you think's going to make? What a difference do you think this is going to make? If you're guessing not a whole heap, Mr. Kulik, you are dead on, barely a quarter. So the takeaway from this example is the number of compounds per year. More is better, but really it's not one of the things to mainly worry about. What's the thing we really want more of? Time. Time is the name of the game for compound interest. You give me more time, and that there is the deal. That makes a huge difference. So for you guys, you young people, you guys have what, like 50 years till retirement, give or take? Say you take some, you save some money and just invest it in like the safest, while still like aggressive investment you can make, like an index fund. You know what an index fund is? It's like a mutual fund that just gives you the stock market, like the Dow Jones percent change, like that's the growth or decline on your investment, is just the stock market, or the Dow Jones anyways, we call that. There's lots of stocks that are not on the Dow Jones, but it's pretty safe because it's really diversified. There's a lot of different investments in there, a lot of different companies. Usually you're probably looking at 7 to 10% gain year over year. You put $1,000 in at 7%. And we'll just assume that's like just simply compounded annually over 50 years. It's $30,000. That $1,000 turns into $30,000. It's a 30 times investment. Now, if you're able to do the $1,000 every year, starting now, you can see where we're getting at here. By the time you're ready to retire, you're probably a millionaire, which sounds pretty stinking doable, but you got to start now while you have time on your side, because that's the kicker. So if you're not saving for retirement, for the future, even at like 16, 17, 18, you're missing a huge opportunity. Like $1,000 a year, not that much money. It's like $100 a month. That's all we're talking about. That's $30,000 in the future, conservatively invested. Whoa. Every year, that becomes pretty big, because once you actually start working, you're going to be saving way more than $1,000 a year. You should try to become a millionaire. Totally doable if you start soon. If you wait till you're 30 to start doing it, much harder to become a millionaire. You start at 17, really saving, totally realistic. Even if you never make that much money in your lifetime. Like you work, humble jobs that don't pay you millions of dollars a year. Compound interest. All right. I have 2 more examples and we're done for today. Sound good? That's my soapbox for you guys. Just trying to make sure that when it comes to be a retired person, you are financially independent. All right. It says Mara has $1,000 and placed it into a savings account with 6% annual interest, compounded monthly. How long will it take before Mara has $4,000? So again, I hear this compounded. So I know I'm going to be using the compound interest formula. I have a present value, I have an interest rate, I have a K, and I have a future value. How long we're looking to solve for n? So we'll fill things in. Where's my variable at in this equation? It's in the exponent. To solve for something in the exponent, what are we going to have to use? Not a square root. Give you a hint, it starts with an L. That doesn't start with an L. A logarithm, that is correct.
Bingo.
So we'll start by getting the exponential part by itself. So divide both sides by 1,000. And I could simplify that, but I'm not going to bother because it's all going to go into my calculator eventually. Now, to cancel out that exponent base, I'm going to use a logarithm with the base equal to the exponent base. So to both sides, I'm going to do log of, or log base, I should say, 1 plus 6 over 1,200. And then pew pew. And then we'll just divide both sides by 12. I'm going to write it as multiplication of the reciprocal. And we're good to go. To get this into my calculator, to choose a log base of anything that I like, I'm going to press math, and I'm going to choose the log base command down at the very bottom. 1 plus 6 over 1,200 of 4. Oops, I forgot to multiply by the 1/12. Let's do that here at the end. And I get about 23.16 for n. Yes. Any questions on what we did there? Relatively straightforward, right? Feels just like the stuff we had been doing. Like the numbers are weird, but like, so what? It's just a number, man. Like, doesn't have to just be like whole round numbers. All right, my last example for you guys today reads, Gwen has $600 to place in a savings account. What annual interest rate would she need, compounded weekly, if she wanted to have exactly $1,500 in 10 years? Okay, well, I see a present value. We're looking for an R. We're given a K, we're given a future value, and we're given an N. So again, compounded, so I know that we're going to be doing the compound interest formula. So fill in everything that we are given. Notice, where is my variable located this time? It's inside the base of the exponential, right? It's not in the exponent. So do I need a logarithm to do this? No, I do not. I will start the same way. I'll just divide both sides by 600. I'm going to simplify that a little bit just because it's easy to do, but I'm not going to worry about like doing all the reducing there that's possible. Everybody's okay with that? I may write that as a vertical fraction. So now to get at the r, I got to get rid of this exponent of 520. What operation is going to cancel out an exponent? Anthony? It's time. What operation is going to cancel out an exponent? It's time for your answer. No! It's your other answer. Well, not a square root, but a radical. More general than a square root. So which radical do I need here? What should the index be for this radical? 520. So we're going to do the 520th root to both sides. So then we'll just subtract 1 from both sides. And then multiply by 5,200. And it's calculator time. So I think we had talked about this previously on how to do these like large indexed radicals on our calculator. So to do the 520th root, I'm going to type 520, press the math button, and then I'm going to use this command 5. So that puts the 520 in the index, and then I can just type in my 15/6. And there we go. So I need about a 9.17% interest rate to do that. Everybody feel okay here? Essentially, all these problems turn into just like an algebra solving problem, right? You just have to interpret what's going on. I think that's good for me for today. If I look at the problems you guys should be able to do now, 39 through 50. Oops, that wasn't what I meant to press. 139 through 150. So that'll be part of this Sunday's problem set. I want to remind you guys, it seemed many of us forgot that we did have a problem set due over the break. So it was 131 to 138 was due technically on Sunday. A lot of you guys had that missing. So there's a reminder to like make sure if you're planning on doing that, you get that done inside of the week and email me about it so you don't rack up a late on it. You always have a week of grace, so no big deal, but this is me reminding you that there was an assignment due on Sunday. Not surprised that many of us forgot about it. That's okay. You have a week of grace, so if you are a junior and need to do that, try to get that knocked out if that's your plan. But that's it for me. Sound good to you guys? All right, I'm done talking.